This video is for number 7 and 15, which are both involving graphs of functions. This is an absolute value graph with a vertex at -3, 1. The equation of an absolute value graph is of the form a absolute value of x minus h plus k. So we're looking for an equation here that has a vertex at -3, 1, which would apply to all of these. The a represents the slope of these lines. This is a positive a value since it opens up, and the slope is up 1 over 1, 2, 3. So with a slope of positive 1/3, we would get this as our answer. On number 15, we have determined the area of the region bounded by all of these graphs. So y equals 6 and y equals -4 are both horizontal lines. And this is an absolute value graph with a vertex at 0, -6, and a slope of 1. So up 1, over 1, so something like this. Alright, so the area of the region bounded by all three of those graphs is a trapezoid. So we can see here this trapezoid. So we need to know the formula for the area of a trapezoid, which is 1/2 times the height times the sum of the bases. So in this trapezoid we have a height, so from -4 all the way up to +6, the height of the trapezoid is going to be 10 units. And then the length of the two bases, so the base down here, if you have a sketch and it's not super accurate, especially if there's no grid here, we just want to verify where these two values are to find the width. So we're at y equals -4. So if we're at y equals -4, and we add 6 to this side, that means x is at 2 or -2. So if we're at 2 and -2, that's a width of 4. Plus the second base, so we're trying to figure out the width from here to here. And again, if your sketch isn't accurate, then we can just look at, if we're at a y value of 6, we're determining what x is equal to. So if we have absolute value of x equals 12, that means this is at +12 and this is at -12. So that's a length of 24. So this would give us 1/2 times, this is 28 times 10, which is 280, and so we would get 140.